Hi guys, Dr. Crafts here with a short summary of epithelium. A couple words about epithelial cells. Epithelial cells have a lot of different functions, but one of the main ones is to line things or to cover things. And so they really need to have a polarity. They need to have a bottom and a top, and they need to have something to sit on. And there's a couple words that are easy to mix up. One is basement membrane, the other is basal lamina. The basement membrane is this whole thing that epithelial cells sit on, and it's actually made up of a basal lamina, a basal layer, and a reticular lamina, a reticular layer. The basal lamina sounds very similar actually, but it's just this top layer that's actually the one that sticks to the epithelial cells. It's also composed of a couple different layers, a dense layer and a clear layer, so don't mix those two up. Epithelial cells are unique from other cells in that they have to have ways to stick together that other cells don't really have to have. Epithelial cells, for example, line the gut, and you want to be able to absorb things through epithelial cells, not in between them. So you have to have a way to stick them together really tightly. So let's go through these junctions really quickly. I'll just point out a few of the things that you need to know. The first one up at the top here is tight junction. It's also called zonula occludens, which is a great name because that's actually what it does. It occludes the space. It seals up the space in between epithelial cells. It usually is right at the top of the cell, the apical portion. And there's a couple proteins in here, claudins and occludens. I like the occludens because that goes with the name. Next one, adherens junction is also called zonula adherens, and this guy is really basically like a sticky belt. It encircles the whole cell, but it doesn't really occlude the space in between cells. It doesn't seal it up, but it sticks it together very well. And there are some proteins in here called cadherins, which is a great name too because it's got the adherens right in it. These cadherins stick out in between the cells and kind of glue them together. Next one is the desmosome junction. This is also called a spot desmosome. And this one is cool because it's just what the name says, it's a spot. It's basically like a little rivet or a spot weld. And there's usually a whole bunch of these all around the cell here and there, just kind of sticking the cells together in little spots. The more of these you have, the tighter the cells stick together. And these guys also have a nice little name for what's inside that helps the cell junctions hold the cells together. The proteins inside, one of them is called desmogliin. And I like that because it's like desmo is kind of like skin. Desmo means skin. And glian to me sounds like glue. So it's kind of like gluing the cells together in that one tiny spot. It's like a really strong glue. Next one, gap junction. This is not really an adhering junction, but it's a pore. It's basically a hole that connects cells so that things can flow from one cell to the other without going all the way outside and coming all the way back in. And there are little things called connexons in there. And the bottom one, hemidesmosome. This is just like a spot desmosome, only it's just half of one. And if you see the spot desmosome up at the top, number 3, that has two things, one on each cell. Hemidesmosomes stick the bottom part of the cell to the basal lamina, so there's just basically one little half of a desmosome, so that's why it's called a hemidesmosome. And these you can think of as little rivets that stick the cells to the basal lamina. And these guys have little integrins. Those are the name of the proteins that stick hemidesmosomes to the basal lamina. Some things on the top of epithelial cells that you need to know the names of. Microvilli are these little projections that stick out of the top of cells. They're really tiny, and the purpose of these is mostly for absorption, sometimes for secretion. They don't move or anything. They just increase the surface area. This is just a dumb name. These guys are not cilia. I don't know who names this stuff, but these are not cilia. Cilia move, which you'll see on the next slide. These guys are basically just microvilli. They're just really long. So somebody had the bright idea to name them stereocilia. I have no idea why. They're not cilia at all. Cilia are different than microvilli. They're longer, they're wider, and the point of them is not to absorb things, but to move back and forth. So you have them like in your respiratory tract to help move the mucus up from the bottom of your tract out, respiratory tract up. So movement. Couple different names for the shapes of epithelial cells. They're basically three, and they have to do with how tall the cells are as opposed to how wide they are. Squamous cells are basically just flat. When you look at them end on, like in this picture, they just look like these little nothing things, but if you look at them from the top, they kind of look like a fried egg. They're much wider than they are tall. Cuboidal cells are just what the name says. They look like little cubes. They're really cute, and they're basically just as wide as they are tall. And then columnar cells are really tall, much taller than they are wide, so that name kind of makes sense too. And then these cells can be arranged in different patterns. They can have a simple arrangement, so this is simple squamous epithelium in the top left, just one layer. You get a simple cuboidal or simple columnar epithelium, just one layer of cells. You can also have stratified epithelium, and that's when you have cells that are in real layers, so that the bottom ones touch the basement membrane, but the top layers don't. They're just all sitting on top of each other. That's stratified. You can have stratified squamous or stratified columnar, not usually, but you can, stratified cuboidal. There's also something called pseudostratified, which is just like the name says, it looks stratified, but it really isn't, because if you look really close at these cells, they kind of look like the nuclei are in the different places, but they really are all touching the basement membrane. If you look really close, some of them might look like they're at the top, but they really do touch the basement membrane. All of them do. If you kind of outline them, you can see that. So that's pseudostratified. And then finally, just a couple words about glands. Glands are made up of epithelium too. There's a couple kinds of glands. There are exocrine glands that secrete, glands secrete stuff, first of all. Exocrine glands secrete things through ducts, whereas endocrine glands basically have lost their duct structure and they just secrete things right into blood. And then a couple, three different words for the way that glandular cells secrete things. And these have more to do with exocrine secretion than they do with endocrine secretion. So merocrine glands are the most common type of glandular secretion, and they just basically just take their little product and they exocytose it into a little globule, and they kind of spit it out at the end of the cell. The cell itself is totally preserved, and everything is kind of neat and tidy that way. Holocrine secretion, I think it's a kind of a good name, though they probably didn't mean it that way, but holocrine glands secrete things by just secreting the whole cell. They don't even bother secreting little granules or anything. They just dump the whole cell out. The cell disintegrates, and whatever's in the cell gets secreted. So whole cells. And then apocrine glands, nice name also, because they basically, the cells remain present, but they secrete by kind of budding off the upper portions of their cells. So the apocrine, the apical portions, not the part that's sitting on the basement membrane, but the part that's sticking out into the duct. So apocrine glands secrete their apical cytoplasm, so that's another good name too. So that's a quick, short summary of epithelium. Thanks for listening.